Hi, in this video, we are going to see how to find vertex of a quadratic function which is given in intercept form. That is y equals to a times x negative p times x negative q. Okay, let's see this stuff with an example. Consider a quadratic function in intercept form. That is y is equal to 2 times x negative 5 times x negative 7. Okay, here this quadratic function is in intercept form. Okay, to get vertex of this quadratic function, my first work is to get the two x-intercepts of this quadratic function. For that, I have to plug in 0 for y. So whenever I not only for this quadratic function, so for any function, so if I want to get x-intercepts, I have to plug in y is equal to 0. When I plug in y is equal to 0, I'll be getting a quadratic equation that is 2 times x negative 5 times x negative 7 equals to 0. Okay, here the product of the three quantities 2, x negative 5, x negative 7 is equal to 0. Whenever the product of two or more quantities is equal to 0, one or more quantities has to be 0 so that the product can be 0. But I'm pretty sure the first quantity 2 cannot be 0 because it's a constant. It can never be equal to 0. So either x negative 5 has to be 0 or x negative 7 has to be 0 because these two quantities contain variable. For example, if x is equal to 5, this quantity will become 0. If x is equal to 7, this quantity will become 0. So because the product is equal to 0, so one or more of these three quantities must be equal to 0 so that the product can be equal to 0. So the first quantity 2 is a constant. It cannot be equal to 0. So either the second quantity x negative 5 must be 0 or the third quantity x negative 7 must be 0. So to solve for x in this one, I have to add 5 to both sides. When I do so, this negative 5 positive 5 will cancel out. I get x is equal to 5. And so here I'm adding 7 to both sides to solve for x. So negative 7 positive 7 will cancel out. I get x is equal to 7. Okay, when I plug in y is equal to 0 into the given quadratic function, I got two x-intercepts. X is equal to 5 and x is equal to 7. Okay, now to get the x-coordinate of the vertex, what I need to do is I have to find the average of the two x-intercepts, 5 and 7. So the average of 5, 7 is equal to 5 positive 7 over 2, which is 12 over 2. Finally, I'm getting 6. So the x-coordinate of the vertex is 6. Okay, now to get the y-coordinate of the vertex, I have to plug in x is equal to 6 into the given quadratic function. Okay, let's do this on the next page. So y is equal to 2 times x negative 5 times x negative 7. Actually, this is a given quadratic function. To get the y-coordinate, I have to plug in 1 second. X is equal to 6. So we get 2 times 6 negative 5 times 6 negative 7. So y is equal to 2 times 6 negative 5 is just 1 and 6 negative 7 is just negative 1. So y equals to, here in front of 2 we have to assume there is positive sign. So here in front of 1 there is no sign, we have to assume there is positive. So positive times positive will become positive, positive times negative will become negative. So 2 times 1 is 2, 2 times 1 is 2. So we get y equals to negative 2. So when I plug in x is equal to 6 into the given quadratic function, I get y is equal to negative 2. So the vertex of the given quadratic function is 6, negative 2. Okay, let's look at one more example. Okay, consider the quadratic function that is given in intercept form, that is y equals to negative 3 times x positive 3 times x minus 2. As I told you in the first example, I have to get the vertex of this quadratic function, first I have to get the x-intercepts. For that, I have to plug in y is equal to 0. When I plug in y is equal to 0, I get negative 3 times x positive 3 times x negative 2 equals to 0. So the product of the three quantities equals to 0. So definitely the first quantity cannot be equal to 0 because it's a constant. Negative 3 can never be equal to 0. So either the second quantity has to be 0 or the third quantity, x negative 2, has to be 0. Okay, if I solve for x in this one, I get x is equal to -3. That is, I subtract 3 from both sides. Then I get x is equal to -3. Then I add 2 to both sides to solve for x. The second equation, that is x is equal to +2. Okay, now I got the two x-intercepts, -3 and +2. Now I have to find average of these two x-intercepts, -3 and 2, which is equal to -3 +2 over 2. So when I combine these two, -3 +2, it will be -1 over 2, which is -0.5. So this is the x coordinate of the vertex. Okay, to get the y coordinate of the vertex, I just have to plug in -0.5. I mean, I have to plug in x is equal to -0.5 into the given quadratic function. That is y is equal to -3 times -0.5 +3 times -0.5 -2. So y equals to -3 times, when I combine -0.5 +3, it will be +2.5. And when I combine -0.5 -2, it will be -2.5. Okay, here, so this is +2.5. So when I multiply this negative and positive, I get negative. Negative times negative will become positive. So y is equal to positive. And when I multiply this 2.5, it will be 6.25. When I multiply this 6.25 by 3, I'm getting 18.75. Already we know that the sign is positive because we multiply this negative and positive. We got negative. When I multiply this negative and negative, I get positive. So the y coordinate of the vertex is 18.75. Finally, the vertex of the given quadratic function is -0.5, 18.75. So already we got the x coordinate of the vertex, that is -0.5, and now we got the y coordinate of the vertex, 18.75. So the vertex of the given quadratic function is -0.5, 18.75.